All right, we're picking up, this is page 110, and I'm on number 1, discussion question. Number 10 appears twice in the X column of the table over here on this previous page. Remember this? Okay, so when we listed all of the inputs and outputs from the set of ordered pairs that we were given, we listed them all in the table, and 10 appeared twice. Okay, how many times is it written in the domain? Well, it's only written in our little mapping diagram once for the domain, because we're just listing what are the possible input or domain values. So we just list it once. Now, for one of the 10s, we got a height of 52. For another of the 10s, we got a height of 53. So there were actually 2 output values for 10. And we'll get to that and what that means in a little while. All right, a function is a type of relation in which there is only one output value for each input value, okay? For every input value, there is a unique output value. That is very important, and I would highlight it. Okay, so in other words, for each x value, you only get one certain y value. Okay, so for instance, this is a function because when we put in 3 into the x, we will always get a particular value, 9. When we put in 3, it's not like we're going to get 9 and maybe some other possibility. Okay, we only get one output value for that input value. Okay, give the domain and range of each relation. Remember, a relation is just basically a set of ordered pairs with input and output values. State the corresponding outputs for the given inputs in context and explain whether the relation is a function. The given relation represents the number of students and the number of classrooms the school has to have for the corresponding number of students. So input is number of students. 40, then you've got to have 2 classes. 45, got to have 3. 50, got to have 4. Your domain is your input values, and they are just 40, 45, and 50. Okay? And that represents your student numbers. Your range is 2, 3, or 4, and that is your number of classrooms. So because the x values, the number of students, is going to determine the y value, or the range, the number of classrooms, okay, this is input, this is output. For an input of 40 students, there's an output of 2 classrooms. For 45, there's 3 classrooms. For 50, there's 4 classrooms. So they're representing this information in a variety of ways, okay? Okay, so you can represent this information as a set of ordered pairs. They didn't actually list the ordered pairs, but they would be 40, 2, 45, 3, 50, 4. So you can represent the information as a set of ordered pairs. You can represent the information in a table of input and output values. You can represent the information in a graph right here. You can represent the information in a mapping diagram, which is one of these down here. Okay? This relation is a function. Why? Because each domain value is paired with exactly one range value. All right, now I'm on page 111. The given relation, remember a relation is just a set of ordered pairs, inputs and outputs. The given relation represents the amount of gas in gallons and the distance traveled in miles from that amount of gas. 10 gallons, 150, 16, 240, 17, 240, 20, 300 miles. All right, so here is your information represented in a table. Here is your information represented in a graph. Here is your information represented in a mapping diagram. Again, they didn't give you the information in ordered pairs, but you could easily do that. 10, 150, 16, 240, etc. Okay, so let's go down here and use the information to answer what the domain is, what the domain represents, the range, what the range represents, etc. Okay, so remember that your domain is your list of x values or your input values, and based on the table and the other information, our domain is 10, 16, 17, and 20, and we put these little brackets around it to indicate that those are our numbers. That's the domain. The domain represents the different amounts of gasoline possible. Let's look at range. Okay, your range, remember, are your Y or your output values. Here they are listed. Notice I do not list 240 twice because it's just a list of our different values. And the range represents the distance that's traveled. So here we go. For an input of 10 gallons of gas, there is an output of 150 miles. For an input of 16 gallons of gas, there's an output of 240 miles. For an input of 17 gallons of gas, there's an input of 240 miles. Maybe those are two slightly different cars. Maybe one's a little heavier than the other one, something like that. For an input of 20 gallons of gas, there's an output of 300 miles. This relation is a function. Why? Because each domain value is paired with exactly one range value. Okay, so again, input of 10, output of 150 miles, etc. Y'all can write that down. So one of the things that's often confusing that I want to make sure that I point out that you're careful about, you have each of your input values. Each input value can only generate one output value. Now, this input value generated 240. This other input value generated 240. But they each have only one output value. The only output value for 16 was 240. The only output value for 17 was 240. Okay? It's still a function. You're going to see later on that there are going to be some cases where it's not a function because you'll have one value listed as an input and it can generate more than one output value. And that's a no-no if it's a function, and you're just going to have to kind of learn to keep those straight. Each input can only generate one output. It could be the same output as another input value, but each input can only be paired with one output. Okay? All right, join me on page 112. Okay. So give the domain and range of each relation and interpret them in context. State the corresponding outputs for the given inputs in context, and explain whether the relation is a function. Okay, so our domain are the input or x values, and that's going to be 2, 3, 4, 5. And our domain is going to represent the number of books sold. Our range is, remember, your y values or output values. X or input. All right, your range 4, 6, 7, 9. And those represent your prices. Okay, so there's a variety of ways that they're representing the same information. They did not, again, they didn't give you the ordered pairs, but they could. So they gave you the information in a table with input and output values. They gave you the information in a graph with input values down here on the x-axis, output values up here on the y-axis. They also gave you a mapping diagram with input and output values. Okay, these are your inputs. Oops. These are your outputs. So the question is the relation a function? And the answer is yes. Why is it a function? Because each of these domain values is paired with exactly one range value. 2 is only paired with 4. 3 is only paired with one value, and that is 6. 4 is only paired with one value, and it's 7. 5 is only paired with one value, and it's 9. This relation is a function. Okay, we're going to slide down and we're going to take a look at number 4. The relation represents the time spent exercising and the number of calories burned during that time. All right, so again, a relation is a set of ordered pairs. They can list them as ordered pairs, or they can put them in a table like they did here. They can put them in a graph like they did here with the domain on the x-axis and the range on the y-axis. They can put them in a mapping diagram, domain and range. Okay? And the question is this relation a function? And then we can also describe what the domain and range is. The relation is a function, and the reason why it's a function is the same reason why this one's a function. Okay? Each domain value is paired with exactly one range value. Okay? This domain value is only paired with 50. This domain value is only paired with 85. This domain value is only paired with 85. This domain value is only paired with 100. Okay? It does not work the other way around. It's how many. We look at the input or the domain, and it can only be paired with one output. Okay? Okay, so I've marked it up, just reminding you that time is your domain. It's your x values. It's your input values. Calories burned is your range or your y values or your output values. We can represent them as ordered pairs. We can represent them in a table. We can represent them in a graph. We can represent them in, what's it called? I don't remember what. Sorry about my brain cramp. A mapping diagram. Okay, then I'm going to list domain. Here are my input numbers. My domain represents time exercising. My range, here are my range numbers or my outputs, and it represents the calories burned. This is a function. The relation is a function because each domain or input value has only one range or output value. Here's the way you can maybe think about this. Let's say somebody decides that they're going to start working out, and one day they spend 20 minutes exercising and they burn 50 calories. Next day they spent 30 minutes exercising and they burned 85 calories. Next day they spent 35 minutes exercising, but maybe not quite as vigorously, and so they burned 85 calories again. Then they spent 60 minutes exercising and they burned 100 calories. So you can see how two different inputs might give you the same output, but you can't have it the other way around. For instance, can I exercise for 30 minutes on a specific day and burn both 50 and 100 calories? It doesn't make sense. If I'm going to input a certain amount, I'm going to get either one value or another. I can't get two separate values. Okay?